thank you for watching. My name is Kaz, otherwise known as Karol Kazmierczak, although my doctor strongly advised me to change my last name because of too many consonants. Well, some of you, particularly those who are located further north or even in different countries on different continents, expressed your surprise and outrage using adjectives like atrocious with reference to the buildings and details that I presented in my facade sky tours so far. Therefore, I thought I would delve a little bit into the details and onto the specific circumstances that they happen to come into being. I realized that some of it may come as a shock to those of you who are familiar with those, but on equally important note, those of my peers who are located here in South Florida remarkably remained very silent. So I'm afraid I stepped on many toes, and unfortunately some of the building consultants located here endorsed the conditions that I'm showing on the videos. Well, thank you again for your attention and your kind words of appreciation. And let me go ahead and describe some of the phenomena seen on those videos. Enjoy! So you may remember those details showing a bridging between the structural slabs and non-structural masonry walls, and remember how they were produced, with the sleeves being drilled through the concrete slabs and the vertical rods placed into them, stabilizing the heads and the bases of the masonry walls. Subsequently, what happens is you get cracks in all kinds of places depending on where those rods ended in the wall, and then an expensive renovation would fail to address the phenomena behind the symptoms. And the process would be repeated after the building fails again at the expense of owners and investors, or if it was our taxpayers' dollars, the management may choose to demolish it instead. So this is the life cycle of a building, with those materials ending multiple times at the landfills of the world. Those exterior non-structural walls are going to be stressed in random fashion. You're all gonna get stress cracks, particularly in weak points, such as propagating from corners of openings, going step-like manner along the head and bed joints of masonry, and connecting miscellaneous openings and other features. And particularly pronounced would be those cracks separating different materials, like structural concrete cast in place, as opposed to say structural masonry or non-structural masonry or other materials. And here are the results. Multiple photographs to choose from. Here is a very expensive property on one of the Caribbean islands that I was asked to investigate long time ago. Here you can see widespread deterioration of interior finishes, choking of the gypsum board, and followed by a significant investigation into the adjacent conditions. You can see the exposed structural concrete header above the curved window, and all kinds of damage that's being caused by the water leaks. Here's the typical view you're gonna see above the suspended ceiling. There is plenty of leaks. There are some attempts of internal sealing, the rotten wood. In those exposed areas you're gonna see cracks. Some of them would be soaked visibly with water that's darker in these pictures, and there would be some water damage here and there, some mold and mildew. There are some salty deposits, particularly visible in a wall like that, which was coated black. You can see those calcified deposit cracks that were patched many times over, and they still live opening every now and then. You would see live leaks during rain, mold and mildew at miscellaneous interior spaces. And in technical spaces, you don't really have to go above the suspended ceiling. You're gonna see those leaks on exposed interior walls, such as in staircases and mechanical rooms, or in a police evidence room, like in this case. Architects and engineers tend to argue with me that concrete walls are impermeable. They design it, I test it. The proof is in performance. Here is a 1 foot deep flat-proof wall that was built and designed to protect ground level from flooding. And you can see it failed in spite of all the good intentions. So the funny thing is that those walls are built according to the actual approved details. Those are structural details from another building, but they are pretty much universally used around here. And you can see all the original scenes of this construction here kind of exemplified, with the head detail bridging the vertical degree of freedom as opposed to having only resisting lateral movements like in every other geography that we know about. Jump details where they actually are free to move vertically. They only provide the horizontal resistance, explaining why those crack much more freely along its actual separation lines as opposed to random bed joints like the masonry does. Some northerners were concerned about thermal insulation in these walls, which we cannot see because we are flying outside. The good news is that I have plenty of photographs from miscellaneous investigations. Here is one, for example, exploratory opening, where you can clearly see the prevailing practice in a hot and humid climate of placing the insulation on the interior side as opposed to the exterior side that northerners suggested. And to be perfectly clear, there is nothing wrong with placing insulation on the interior side. This is actually one of the very few climates where it's permissible and perfectly okay. Here is a very good example of an expensive thermal insulation. It's called polyisocyanurate. It actually does its job, right? It creates a large thermal differential. How do we know it? We know it because it generates lots of moisture. It's applied in discontinuous fashion, which here is the main culprit. So this exterior wall, which is soaked with water, not only because it leaks, but it's also very permeable to the hot and humid air. All that moisture can easily permeate through the cracks and gaps of the polyisocyanurate insulation, and it meets the surface of the gypsum board. That's why it's covered with mold and mildew, because it's almost always covered with condensation. Almost always when I see moisture damage like that, the claim is actually the opposite. An owner would tell me, hey, a contractor must have screwed up and didn't put enough thermal insulation. And they never believed me when I explained that the thermal insulation coupled with incorrect detailing is the actual reason why they have moisture problems. So local contractors learned the hard way and started economizing. This is the material they typically use these days as a thermal insulation. It's composed of several layers of paper coated with aluminum, which is a very good vapor barrier. One building owner complained to me that his building, insulated with this particular material, has twice the utility bills, the electrical bills, than his neighbor whose house was built long before those building codes were introduced. The company never provided me with the actual testing reports that I requested numerous times. The company in response typically blamed contractors who were installing its product because frankly its installation is incredibly tricky as it's seemingly easy, just stapling it to the furring. The proof is in its performance. You can see it's installed in front of as leaky concrete walls as before, yet I haven't seen a single gypsum board or sheetrock damage behind the continuous build of such an insulation. You would see strange things like water dripping from electrical outlets and electrical switches where that vapor barrier is discontinued, but not in a field. And that particular aspect of performance allows contractors peace of mind in installing impermeable materials on the interior side of walls, such as, for example, the tiling of the wet rooms, such as bathrooms and kitchens. Here you can see a picture showing where the leak is coming from. It's coming from the opaque assembly as opposed to the window. Yet it was the fenestration provider who was bullied into coming back on the job site to fix his work. So this material acts as a vapor barrier installed on the wrong side of the wall, which isn't a big deal in case of concrete walls, which just stay wet because they leak just as they leaked before, but it creates a challenge in case of framed walls, particularly those made of wood framing. And as a result, the company started perforating its own product to make it more vapor permeable. And this is how we segue into the next topic of my facade sky tours, is the sills of the fenestrations. You can see that it's not easy to determine which one is leaking. Is it the fenestration or is it the opaque wall next to it? The reason for it is because the corners and the corner flashing of such a fenestration is typically not done very well, and it's a toss. There are many symptoms, including damage to the millwork, damage to the furniture. You would see rusty fasteners when you pull a carpet. You would see water popping up from below the flooring. In the past, when there was a doubt, I used to provide flat testing at the sills of such fenestration. This is an example from a very expensive resort in Bahamas, where it took me a while to realize that not all adjacent walls are made of concrete. Some of them are actually built out of plywood with some stucco outside. So here is an exploratory opening along the base of the wall, where there is not only some formwork left inside, but it's also rusting, rotten. You can see water sensitive tape not changing color yet. Here is another example of a flat testing after the existing terrace flooring was demolished, the new waterproofing installed. You can see water seeping not only at the base of the fenestration but also through the base of the wall, which in this case is elevating, masking the leaks that are happening below. Here is a very interesting example of building a Swiss watch along the very, very long terrace with only a couple of inches of depth available to drain the sill of the sliding windows or sliding doors with this 3/4 inch diameter PVC pipe. Obviously all the slopes are in reverse, and the sill itself is not that easy to seal. Here we can see an exploratory opening on the months after it was finished. So those are also built strictly according to the architectural details. You can see one of them here with the head, which serves also as a jamb. And such a combination is already a very strong red flag and a warning sign that something is wrong with the drawings, because the two cannot be combined really. And a seal. Not a trace of a weather resistive barrier, not a trace of drainage path, nothing that would make it even remotely code compliant. You may remember that the international building code that got implemented into all state building codes actually requires the architect to draw these. I have tens of such inferior architectural sets in my records, but blurring and removing the identifying information is kind of tedious, so I'm just going to show 2 or 3 projects. Here is an interesting one. This is why I included it. This very expensive beachfront tower in Bahamas was built on basis of these drawings. The architect came from Vienna, Austria, and you can immediately see the influences. The way this facade is represented is generally right. We can see roller shades, very important. In almost every climate you can see almost continuous thermal insulation, very good of German fenestration. You can see waterproofing and the elevation of the sill. He forgot about some important details though. This type of fenestration typically come with the additional pieces of extrusion that serve for specifically to tie in the adjacent membranes. He didn't draw that. Obviously he didn't draw any weather resistive barrier on the wall. And unfortunately there are telltale signs throughout this set that tell me that this architect didn't know what he was drawing. For example, it's enough to have a look at those 4 wood screws placed in the corner areas of reinforced concrete beams, locations where even dedicated concrete fasteners wouldn't do their job. And unfortunately contractors built it the way they interpreted it. I also mentioned roofing, which is a component naturally very well visible from the air, and also because I am characterized by my irresistible urge to drill holes in the roofing searching for water. And sometimes beyond my wildest imaginations, water actually erupts like a geyser. And then underside the slabs you can see all kinds of things, including stalactites like here dripping on somebody's head, which is even more impressive when it's painted black like in this case. And it's clearly coming through the solid concrete. Somehow magically concrete opens cracks and water is able to percolate through it in spite of miscellaneous claims to the contrary. And then there are incredible contraptions built to catch this water. You can see those above, suspended ceilings sealed to the window, with a crust of green algae. It's been there for years, with a garden hose plumped into the drainage system of the building, directing that water outwards. There are pretty incredible things for those who have eyes to see. So for all of you unfaithful northerners who cannot believe what I show you, this is all true. Now you've seen it with your own eyes.